Welcome to qnawire.
This problem asks us to show that the angle of friction, denoted as lambda, is less than or equal to the tangent inverse of the coefficient of friction, denoted as mu, or simply lambda is less than or equal to tangent inverse of mu. To prove this identity, we will first consider a body lying above on a horizontal surface. When a force is applied on this direction, applied on the body, we denote this force as F sub A, or the applied force. The other forces acting on the body are its weight, pointed vertically downwards, denoted as F sub W, the normal force, which is perpendicular the horizontal surface, and the friction force, which is opposite the applied force, denoted as small f. We'll now consider another force, which is the resultant vector of the friction force and the normal force. This force is called contact force. Let's denote this as F sub W. I said sub C. Sorry. And the angle between the contact force and the normal force is called the angle of friction. Now, using trigonometry, we'll derive an expression for the friction force and the normal force involving the contact force. As such, friction force is equals to the product of the contact force and then the sine of the angle of friction. And normal force is the product of the contact force and the cosine, the angle of friction. Isolating the contact force to the left side of the equation, then we can express this two equation as Fc is equals to sine inverse over friction force and Fc is equals to cosine lambda over the normal force. Equating these two equations to each other, we have sine lambda over friction force is equals to cosine lambda over the normal force. Since we need the tangent of the angle of friction, we can express this equation as sine lambda over cosine lambda is equals to friction force over the normal force. As such, tangent lambda is equals to friction force over the normal force. Now let's get back to the applied force, or the force applied to the body. When this force is not strong enough, the value of the friction force is less than the product of the coefficient of friction and the normal force. And at this instance, the body will not move. If the applied force is increased further, it will reach a point wherein F will now be, the small f or the friction force will now be equal to the product of the coefficient of friction, and normal force. When this happens, the body will now move. Now, let's get back to the instance where just before the body moves, or where the value of friction force is less than the product of the coefficient of friction and the normal force. Inserting this expression to the equation we have for the angle, which is this one, then tangent lambda is equals to less than the product of the coefficient of friction and the normal force over the normal force. Simplifying, then tangent lambda is less than or equal to coefficient of friction. Isolating the angle to the left side of equation, we have lambda is less than or equal to tangent inverse of the coefficient of friction. As such, the tangent of an angle is always less than or equal to the coefficient of friction.